Hello. I recently had to rebuild my home lab, my kind of lab testing environment, etc. It's about 20 virtual machines, a couple of bare metals, and some of them I cannot update for various reasons. And I kind of want to go and start using Puppet Apply for those rather than keep my old Puppet server around. And this led me think about a couple of problems in the space around Puppet. For Puppet Agent, we have problems if you use too many agents running at the same time. They perform a DDoS against the Puppet server. And there's been various solutions to this in the past. People just use FQD and RAND to spread them out against the cron job, for instance. This works okay. At some point, you're still going to run into problems with that approach because the runs tend to bunch up when the Puppet servers are running out of resources. Other solutions which M Collective had in the past was a thing called run all, which would query the fleet, figure out how many machines are currently applying manifests, and then only start new machines when there's capacity available. This worked okay for one shot, just one interactive use, but it wasn't really a solution for the general problem. In Choria, we have a better solution that essentially makes every Puppet run into a run or run, which means is every Puppet run from a cron will run as quick as possible given the constraints of the Puppet server and without someone having to drive that process. It's automatic. The way it does that is using a thing called governors. And so here, for instance, I'm adding a governor called Puppet, and I'm giving it a capacity of 10. Now the capacity is about slots inside the governor. And so what it means is if 1,000 machines start up at the same time, all trying to run Puppet, and if that Puppet run is constrained by the governor, what means is 10 of them will actually start running Puppet while the rest of them will wait. Then as soon as there's one finished, another one will get its slot and he will start to run. This happens automatically in the background, no orchestration required, it just happens. And so you add the governor, could also use it using a Puppet resource. And then you simply add a cron job. You don't have to fiddle with the minutes or anything like that. It's quite nice because you know when your code is going to go out, it's going to be on the half an hour as quick as possible. And so you say Choria governor run, you give it the governor name, some stuff, and then the command. It will then, on the half an hour, start all of your machines, and they will get slots on the governor, and as quick as possible, the number of machines that's there will finish their runs, no more than 10 at a time ever. We have users using this, it works pretty good. We have users using this on thousands of machines, and I've used governors on a very large scale, 50, 60,000 machines at a time. So very happy with this capability. Now, for Puppet Apply, the problem is a little bit more involved because we have to get the code onto the machines, and I want the code to be delivered to the machines in a declarative way. In other words, I want to know that if a machine is down, at the time where I run my SSH for loop to copy the files out, that when that machine comes up, he will still get the code. And so SSH for loops or whatever is not an answer to that solution. We want the code checkouts to be done declaratively. We also want that if ever there's a change to the code on the machines, someone changes the Puppet code lying on the disk, that change gets detected and remediated by deleting the code that's there and downloading new code. This implies that there's some checksumming and all this kind of stuff happening. We want it to be a thing where you basically, maybe we have a key value store. And so if we put into the key value store that says, this is a code to run, the machines must just figure that out on their own. Of course, the code gets downloaded against a web server, and so I want to control the concurrency against the web server, because once you have enough machines, that'll become a problem. How many of them are downloading a tarball? And so again, there a governor comes into play. Finally, to do the Puppet applies, there also, of course, a governor to do the runs. Why would we want that? Because it's not like there's any shared resources. Well, within a cluster, you may have a mix of machines, databases, and web servers, and so forth. Now, if you start all your Puppet applies at the same time and things are being restarted, it might mean that there's a coordinated outage because everything will restart at the same time or near enough at the same time. This could be a problem with your databases. Maybe you would always want to ensure that there are a rolling upgrade, essentially one at a time. In your web servers, they can stand a little bit more of them being down. Maybe there you run 10 at a time. So how do you coordinate a Puppet apply in such a way that some subsets of machines are doing 1 at a time, rolling deploy, others are doing 10 at a time, others are doing 5 at a time? It's a very difficult thing to do. And so if you were to write code to do that, it would be very, very complex code. Now I'll show how I've done that using a couple of capabilities together. Our autonomous agents to manage the on-node process, our key value bucket to manage the desired state of the code, and our governors to manage these runs. Yeah, so let's just get into that. I'll demonstrate how this works essentially. So I have my code here. It's like super basic code. It's just gonna be, you know, stick the five into a file. I'm about to make a change here. I'm going to change this into a 6. And I want to get that code out. I have a little command that I wrote, and we'll look at that in a second. Bundle. And code. It is now gone. It has created me a version bundle of this code into a file called that. It has generated a SHA-256 file for every single file inside this tarball. It's put the SHA-256 into the tarball, and it's also done a SHA-256 of the tarball itself, a 256 SHA-256 of this file, and then inside this file is SHA-256 for every file that's inside the tarball. And all of that is within this file. Now, what it means is I can download the file into a 10 directory and make sure that the file is the desired state. Is it the correct file? I can then untar it into a staging directory and say, has the verification file been changed? Because I have its checksum. And then I can use the verification file to verify every file inside the tarball, so I know that every single thing is bit for bit accurate. If I did this check very regularly, I would detect any unexpected changes to the code that my Puppet applies are also running. And if then I trigger a re-download of the new file, if ever there's a change, my code's being remediated. So what I'm going to do is I'm going to copy this file that we just made onto a web server. Yeah. And then I'm going to go p-control code release. I'm going to tell it where I just put this code. It's going to be there. I'm going to tell it the checksum of the tar file and the checksum of the sums file. This gets placed into my key value bucket, and the nodes that are managed by this capability will now get the KV update. They will notice that their code on disk doesn't match the desired state, which is what I just wrote. They will then download a new file and replace that code with new code. And after replacing the code, they will trigger a run as soon as possible. In other words, this change that I made is going to go out as quick as possible, constrained by the governors that I mentioned earlier. So I'm going to give that a minute, and I'll be back afterwards because I don't check the code literally every second. So neither do I check the KV buckets every second. So there's a little bit of wait. I'll be back once that's done. Okay, so it's been just over a minute, and if we go look at this, the machine has now been modified. Choria machine p-control code. We will see we have our code there. We'll see it's a new one that I just edited to 6. This is the generated SHA sums, and you can see that file is correct. It has a way to verify that. The apply ran, and I have a 6 in my file, and so everything's good. Now what I'm going to do is, just for demonstration here, I will change this file. I'm just going to turn that into a 7. And we can give it a minute again. And the system will have noticed that I've changed this file. And it will download a new copy of the tarball that is described in the KV bucket. And so, as long as you control access to the KV bucket, the code deploy on the machines are health checked and reliable and remediated if there's problems. Again, I don't check the code literally every second, so this takes a little bit of time, but it'll be fixed in a minute. Now, this is the basic flow that I'm after, to show the system is doing all these runs and these deploys and the control state and everything happens automatically. I'm going to take a quick look at this control tool that I have here. Initialize will set up the governor and the KV bucket I need. You pretty much saw this bundle and release. State will only show you what's out there and what is the current desired state against the fleet. I have a thing called nodes. If I say find, and I'm just gonna constrain this so you don't see all of my machines. This will find machines that is being managed by this system, and so it gives you an access to just verify that those are the machines out there that's being managed. Before I show the rest, let's just see. Okay, so this got remediated back to 6 now. So you can see that the background process of checking the code, of running Puppet, all that kind of stuff is happening without my involvement, without any interaction. Really good. Okay. Now, I can ask for the state of these machines, and we will see that they're all in something called schedule state. I'll show that in a minute, what exactly that means. What I can do is I can move them to a maintenance state. So this is almost like Puppet apply, but what it actually does is it tells the controlling software, this operator, to stop scheduling Puppet applies, to stop fiddling with the source code, to stop polling the key value store. It's just stop all operations. At this point, Puppet is not disabled as in Puppet disabled. I could, of course, do it that way. What it does, it just stops scheduling. And so if you were to log into the machine, you could still Puppet agent --test or so. That'll continue to function. Of course, when you're done, you can resume. It will then immediately check the KV, immediately check the code, and immediately schedule a run. So after maintenance, it is now doing again what MCO Puppet Run all used to do, which is just run them all as quick as possible. We can watch. This will. You can see there's a machine that's just ran a Puppet agent. So this will show you real-time events of your managed fleet, and you'll see this changes as they go through the life cycle of the thing and what they're running, how long it ran, was it successful, all that kind of stuff. Let's see what else we have here. We've shown that, trigger, find. Yeah. And so this is a very tiny little command. Now you would think, I wrote some code or something for this. This is using something called app builder, and so this command that you're looking at is just a YAML file. So let's take a little look at the autonomous agent stuff. Now, as I was describing the flow of how I'm managing the source code and the Puppet runs and so forth, it looks like this. Initially, we start off in this initial state. We don't know anything. We pull the key value bucket. We get the desired state. If the key value bucket is done, it will just continue to poll until it gets it. Once it has a new desired state, it moves up to checkout. Checkout is the thing that's downloading the code, untarring it, verifying it, and so forth. It will then go, once that's deployed, into scheduled, and in that point, under scheduled, it will run scheduled Puppet runs, obviously, and regularly check the code. If there's a change to the code, key value changed, it will go again into checkout, which will download the new code, which will move back to scheduled, which will immediately run. And then it will schedule every half an hour. I can do a force run, which will change the state into force run, sleep a little bit, and get back into scheduled, which will trigger an immediate run. I can move into maintenance. Maintenance has no activities that runs during that state. And finally, I can resume. That brings us back to the beginning where it will poll KV, fix code, start Puppet runs. That is the flow of the quote-unquote operator that's being used to manage the Puppet run. And if you've written a Kubernetes operator, you'll understand this is a nightmare. It's no easy task. But if we go look at this one, we'll see we have a machine.yaml file. And this is essentially the operator. So we can see I described the transitions. If I go to maintenance, if I trigger the event maintenance, it'll move the machine into maintenance, but only from these 4 states. So if we look at the picture here, the maintenance event, the maintenance event, the maintenance event, or the maintenance event from any of these 4. And so you just draw out the states that you want to have and what updates are possible. And then you attach something called watchers to each event. So here I have a KV watcher. It will try every 90 seconds until forever, basically, until it's able to get the desired state out of the key value bucket. Once it gets to the desired state, it will trigger this update code event. We go back to our picture. There's the update code event that moves from initial to checkout. And over here we got check out the code. It's an archive, and it will every 1 minute it will verify the archive is valid, and so it will do all the health checks and everything. We can see that I'm accessing data, and this is the data that came from key value, and so it understands the data in the key value is a hash, and so I can look up into that, and it fills this data in. So every time that this checkout runs, it will get the most recent data that was obtained from KB. If ever it downloads successfully, triggers to schedule Puppet. And this is governed by the control checkout. Let's skip a bit forward. Here we have schedule. This is the Puppet runs, which you can go Puppet apply. We do that disowned from the terminal so that Puppet apply can restart Choria without killing itself. And that is under a separate governor. And so where I was saying about databases and web servers having different governors, you just have to prepare the governors and give this point a different named government per role or per however you want to chop and change it up. And that's it. So this 107 lines of code is the entire operator that does everything I just described. This 107 lines is all there is that runs on the node. You put the YAML file on the node and it will forever manage Puppet. It will manage the code, it will health check the code, it will remediate any changes to the code, roll out new code. All of the stuff I've been described is encapsulated in 107 lines of YAML. Again, as I said earlier, if you've ever written a Kubernetes operator, you'll understand that this is a huge simplification. Now, I'm not suggesting that this is on par with Kubernetes operators, but for many of the kind of things that we run, like this, or like cluster rollouts, or things like HVACs, like you want to turn your dehumidifier on and off depending on some kind of a metric, these things can do it, and it's very appropriate for that. So it's the kind of controls that runs near on the furthest of edges on your infrastructure, and they run autonomously, hence the name autonomous agents. Now, I've run these things at tremendous scale. I'm talking about tens of millions of active autonomous agents on a network doing things like the continuous delivery software that deploys software to a very large scale of fleet, north of 7-figure of nodes. And by turning every package that's managed into an autonomous agent, we can do a full 7-node figure rollout of code in less than 20 minutes with a very high level of success. You can extend in here. This thing has monitoring capabilities. I need to change my monitoring a little bit, but so that included in here could be the health check that will, see if there's any Puppet resource failures. That they will go into Prometheus metrics, and you can write alerts if there's any failures and stuff like that. All of that with just this basic YAML file. So that's pretty cool. Now let's have one more little look at something. This p control command. This is built using something called App Builder, which you can read about on its own website, Choria App Builder. And it really is a tool for building UIs, you know. And so if you see here, I have a very simple thing that says demo say hello world and demo think hello world. And I wanted to make little cows, right? And if you give it this YAML file, this describes these two commands, arguments, commands, help output, the whole works. And all you have to do is give it this YAML file. And so let's take a look. Choria tool builder list. It shows me I have my pcontrol app. And if I look at that file, we can see it's a YAML file. So if I do pcontrol, Choria puppet controller, there it is, Choria puppet controller. We got commands, and so initialize takes some arguments. Let's say initialize. You can see I can pass some arguments, they have help, they have validations, all this kind of stuff. And these describe the flags. And finally, this is a script that's going to be running. So it's just a bash script, you know, it says things and it runs commands. And so in this manner, the entire pcontrol UI that you saw is just 200 lines of YAML. There's no code had to be written, no shell scripts had to be written, no Go code had to be compiled or anything like that. It is just a YAML file. And so everything I just described to you, the management of it, the interactivity, the ongoing management, the code deploys, the code health checks, all of this stuff is done using two sub 200 line YAML files. And this for Puppet Apply is a really nice outcome, I think, and it gives you a really highly reliable yet highly controlled way of managing a fleet using Puppet Apply. Of course, the same idea can be applied to Puppet agents. So I was saying earlier about different governors per role or per profile, web servers, databases. You could run your Puppet agents in the same way. I am doing this using a Puppet module that sets it all up, of course. I will hopefully in the next couple of days stick that Puppet module on GitHub, and you can take a look. But I've moved all my machines, even my Puppet agent runs away from the cron method to this method instead, so that I can later on say certain machines have a faster runtime and others higher concurrency, lesser concurrency, etc. And it's a really powerful concept. Okay, good. That's all I wanted to show today. Thank you very much.